Whenever you watch one of those really high-end nature documentaries, there is always that unspoken, well, maybe not unspoken, but that behind-the-scenes rule they talk about, the observer's rule.
Oh, right. You never, ever interfere.
Exactly. Like the prime directive of wildlife filmmaking. Even if you see, I don't know, a baby antelope struggling, the camera crew just has to sit there. The whole point is capturing the untouched reality of the situation, no matter how difficult it is to watch.
Right, because it's pure observation. You're just a fly on the wall.
Yeah. But imagine if that baby antelope, just by doing its natural thing, started completely ruining the aesthetic of your own carefully curated living room.
That would be a problem.
Right. Suddenly that strict rule of non-interference gets a lot harder to stick to.
Yeah.
And today, welcome to the deep dive, by the way. Today we're unpacking a philosophically rich set of notes on plant care, specifically looking at the Coleus plant that perfectly captures this tension.
It really does. It's a fascinating case study.
How do you observe a living thing's true nature without letting it completely fall apart structurally?
Okay, let's unpack this. The source notes we have outline a very deliberate, almost counterintuitive methodology for attempting this tightrope walk between pure observation and just the basic necessity of maintenance.
Yeah, the methodology starts with absolute restraint, like total hands-off. The author of these notes has a strict protocol when bringing a new plant species into their collection for evaluation.
Right.
And it is entirely hands-off. No fertilizer, no pruning. The only input allowed is just regular watering.
Which, I mean, that feels completely backwards in a typical gardening context, right? Usually the immediate instinct when you get a new plant is to optimize it.
Oh, absolutely.
You want it bigger, faster, brighter. You want to see results. But the stated goal in these notes is to evaluate, or rather simulate, the plant's growth in a wild environment as much as possible. They specifically want to let the plant do its thing so it can flower naturally.
Right, which then allows them to harvest the seeds for further propagation. Yeah. And when I read this, it immediately reminded me of that parenting and education movement. Unschooling.
Oh, yeah. The parallel is very strong there.
Instead of putting a kid in a highly structured classroom with a rigid curriculum, which, would be the fertilizer and the pruning in this plant analogy, you just open the back door and let them run completely wild in the backyard.
Just see what happens.
Exactly. You provide the basic sustenance, the regular watering, so to speak, and then you just sit back and watch. You want to see what games they invent on their own. What are their natural inclinations when left entirely to their own devices? You're removing the artificial constraints to see the authentic behavior.
And that authentic behavior is critical for understanding the organism you're dealing with. You're stripping away the expectations placed upon the system by an external manager, right?
Yeah.
And you're observing what the system prioritizes on its own.
Right, but I have to push back a little bit on the source material here, though.
Okay, go for it.
Because I'm reading this and I keep thinking, is it truly a wild environment? We are still controlling the environment by giving it regular watering. We've placed it in a dedicated collection for evaluation, likely with controlled temperatures and filtered sunlight.
Yeah.
It's not actually out in the harsh wilderness fighting for survival against droughts and, pests.
No, definitely not.
It's more like a very comfortable zoo enclosure.
Yeah.
So how wild is that, really?
What's fascinating here is that wild is doing a lot of heavy lifting in that description. You're right. The author isn't trying to subject the plant to the actual hazards of a native ecosystem.
Right.
They aren't trying to see if it can survive a 2-week drought or like a massive aphid infestation. Instead, they're trying to establish a pure, unmanipulated baseline. Think of it as a control group in a scientific study.
Okay, say more about that. What are we actually trying to prove with this control group?
Well, in any evaluation of a new species, or any new system for that matter, you need to know its intrinsic capabilities. By deliberately withholding fertilizer, which artificially accelerates cellular growth, and by withholding pruning, which artificially dictates the physical shape, you get to observe the plant's authentic timeline.
So you're seeing what it does when it's not on steroids, basically.
Exactly. You get to see exactly how long it takes to naturally reach the flowering stage, and exactly what kind of seed production it manages on its own baseline energy reserves. If you pump it full of synthetic nutrients from day one...
You don't actually know the plant.
Right. You have absolutely no idea what the plant is actually capable of on its own.
So the wild aspect isn't about danger or neglect. It's about the absence of artificial enhancement. We are looking for the baseline metric of performance.
Yes. And this is a mindset that stretches far beyond gardening. For you listening right now, think about your own learning process or how you tackle a new project at work.
Oh, that's a good point.
When you're handed a new subject or a new team or a new piece of software, the temptation to immediately tinker and fix things is overwhelming. We jump right in, changing settings, implementing new rules.
Trying to optimize the workflow before we even understand it.
Exactly. We want to apply the fertilizer right away.
Because we want to feel useful. We want to feel like we are managing the situation.
Right. But if you don't step back and observe the baseline first, you won't ever truly understand the underlying mechanics of the system you're managing. You won't know if your interventions are actually helping the team become more productive, or if you're just masking the system's natural cycle with artificial, unsustainable energy.
Wow.
You gotta let the system run wild in that baseline state just long enough to reveal its true nature.
Okay, so the ideal is established. Absolute baseline observation. Let it run wild to find the truth of the system. But because this hands-off approach is the stated ideal, we kind of have to look at what actually happens when this high-minded philosophy crashes headfirst into the physical reality of a specific plant.
Yeah, the rubber hits the road.
Right. And in this case, the reality of the Coleus.
And the notes are very frank about this. The hands-off approach creates a highly visible, undeniable problem.
Yeah. When these Coleus varieties are left entirely alone to grow naturally, they become, quote, leggy and sparse.
Right.
Instead of being those full, lush, bushy plants you see in a nicely curated garden center, they get stretched out. They become thin. I keep picturing an awkward teenager,
Oh, that's a great way to put it.
like the kid who suddenly grew 6 inches over the summer, and they haven't filled out yet. They're just all elbows and knees, totally disproportionate, pushing all their energy upward as fast as they can.
Exactly.
That's a leggy plant. And the notes admit that pruning, or what they call pinching back, is technically necessary to prevent this from happening.
Yeah, because the author is observing a structural flaw directly from their control group experiment. The natural state of the Coleus, when left unmanipulated in this specific environment, is to prioritize vertical height over lateral density.
It just wants to be tall.
Right. And because of that, it becomes structurally weak.
But this is where I get hung up again. If the entire point of this exercise, as stated in the notes, is to let the plant grow naturally so it will flower and you can harvest the seeds, why is becoming leggy and sparse viewed as a problem that needs to be prevented at all? Like, who cares if it looks like an awkward teenager?
Right, if the seeds are the goal.
Exactly. If the seeds are the ultimate goal, shouldn't we just accept the ugly phase? Why does the aesthetic sparseness matter?
If we connect this to the bigger picture, it's a fundamental question about the purpose of the observer. What we are seeing here is the clash between pure observation and long-term curation.
Okay.
The author isn't a scientist in a sterile lab running a single disposable test where the subject is discarded after the data is collected. They refer to maintaining their collection.
Ah, right. A collection implies stewardship.
Exactly. It implies that the physical health and the structural integrity of the subjects actually matter over a timeline of years.
So it's not just about extracting the seeds and then throwing the parent plant in the compost pile.
No, not at all. And a plant that becomes severely leggy and sparse isn't just aesthetically unpleasing. It becomes physically vulnerable.
Like it could break.
Yes. It is building a skyscraper on a very thin foundation. A heavy rain, a strong gust of wind, or even just the weight of its own flowers could cause that leggy stem to snap before it ever finishes the seeding process.
Oh, wow. So it literally defeats the purpose.
Right. So the tension becomes a practical one. How do you accept the natural tendency of the plant to stretch out while simultaneously shaping it so it can structurally survive long enough to fulfill its biological purpose within your curated collection?
Man, it's the universal struggle of maintaining anything, isn't it?
It really is.
The clash between accepting things exactly as they are, flaws and all, and the responsibility of intervening so they don't literally collapse under their own weight. We want the authentic baseline, but we don't want a pile of broken stems.
Which means the author's strict hands-off methodology has to adapt. Pure observation revealed the systemic weakness, the legginess. Now they are forced to introduce an intervention. But the challenge is finding an intervention that doesn't destroy the original goal of letting the plant flower naturally.
Well, since we've firmly established this conflict, the desire for natural flowers and seeds versus the desperate need to avoid a structurally sparse, vulnerable plant, we get to look at the specific compromise the source material reveals.
And it's a very clever one.
It is. Instead of doing a full prune, which would mean hacking the whole plant back and totally ruining its chance to flower, the author uses a clever workaround. They take cuttings specifically from the stem tips of selected plants. Just the
Okay.
tips.
A highly targeted, minimal intervention.
Here's where it gets really interesting. I like to compare this to a strategic compromise, like taking just a tiny trim off the ends of your hair to make it grow thicker while still keeping the overall length.
That's a great analogy.
It's so elegant that a single action, snipping the tip, solves two problems at once. It stops the legginess and fulfills the need for new plants.
Right. But to understand why this specific action is so profound, we have to look at the underlying mechanics. We have to look at why snipping just the tip of the plant radically alters its entire structure.
Yeah, let's get into the biology of that, because on the surface, it sounds like magic.
It does.
The notes say that the single minimal action of snipping the stem tips directly encourages bushiness in the parent plant. It stops the legginess dead in its tracks. How does taking a fraction of an inch off the top change what's happening further down the stem?
Well, it comes down to a botanical concept called apical dominance.
They build the whole moon.
Right. At the very top of that main stem is the terminal bud. That bud is essentially a hormone factory.
Oh, yeah.
It produces a class of plant hormones called auxins. Now, the plant's evolutionary goal is to outcompete its neighbors for sunlight, so it wants to grow as tall as possible, as fast as possible.
All right, reach for the sun.
Exactly. The terminal bud produces these auxins, which flow downward through the main stem. And the primary function of those downward flowing auxins is to actively suppress the growth of the lateral buds, the little dormant nodes on the sides of the stem.
Oh, so the plant is chemically forcing itself to focus all its energy on vertical growth. It's telling its own side branches to stay dormant so it doesn't waste energy growing sideways when it needs to reach the sun.
The mechanism is entirely chemical. So when you take that cutting, when you snip off just the stem tip, you are physically removing the terminal bud. You are removing the hormone factory.
Which means the downward flow of auxins suddenly stops.
The suppression is lifted. Without those auxins keeping them dormant, the lateral buds on the sides of the stem suddenly wake up.
Wow.
The plant redirects its growth energy outward. The side branches start growing vigorously, filling out the space. That is what creates the bushiness. You aren't just making the plant shorter, you are chemically reprogramming its growth priorities.
It makes me think of damming a river.
Oh, how so?
Well, the main stem is the primary fast-flowing channel. The auxin is the current. When you dam up that main channel by snipping the tip, the water doesn't just disappear.
Right.
The pressure forces all that water to spill out into the smaller side creeks and tributaries. You flood the entire river basin. You are physically redirecting the system's energy from a single narrow path into a broad, stable network.
That river metaphor perfectly captures the redirection of energy. And the elegance of this specific compromise in the notes is that it solves two massive problems simultaneously.
Yeah.
First, through apical dominance, it forces the parent plant to grow those lateral branches, stopping the legginess and creating a structurally sound, bushy foundation. Second, those snipped terminal buds aren't thrown away.
Right, they become the cuttings.
Exactly. They are the exact biological material needed to grow entirely new clones.
You solve the structural weakness of the current generation,
Yeah.
and you secure the physical resources for the next generation, all with one tiny snip.
And by choosing to only take stem tips and doing so only from selected plants, the grower balances both of their seemingly contradictory goals. Think about how this plays out across the whole collection. The unsnipped parts of the collection are left entirely alone to fulfill the original mission. They continue their wild simulation, they flower, and they produce the seeds for the baseline evaluation.
So the pure baseline observation is still happening. We still get to see the natural life cycle.
But on the selected plants, the targeted intervention secures the structural integrity of the collection and provides the clones. The notes specifically mention that the author is leveraging this knowledge to maintain the collection moving forward.
Leverage, that's the key word.
They identified the exact point of highest leverage within the biological system. Not digging up the roots, not chopping the main trunk in half, just the very tip of the stem.
Minimal intervention for maximum yield. It is the absolute antithesis of micromanagement. It requires understanding the underlying mechanics of the system so intimately that you know exactly which single string to pull to bring the whole thing into balance.
And for you, the listener, the takeaway here extends far beyond botanical science. What we've really been unpacking today is a universal framework for managing any complex system or any long-term endeavor.
So what does this all mean? Like a blueprint for observation and action, basically.
Precisely. Whenever you are faced with a new environment, a newly formed corporate team, a new community project, a new piece of complex software, this framework applies.
Right.
Step one is resisting the urge to immediately prune and fertilize. Observe the baseline. Let the system run wild just long enough to reveal its true nature and its intrinsic capabilities.
And step two.
Step two is paying close attention to where the system naturally becomes leggy and sparse. Where does the process naturally weaken? Where does the team's energy get stretched too thin, threatening the structural integrity of the project?
And step three is finding your stem tip. You don't tear the whole system down and rebuild it from scratch to fix that weakness.
No.
You don't micromanage every single lateral branch. You look for the terminal bud. You find the most minimal strategic intervention, the single point of leverage that redirects the energy to solve the weakness while simultaneously yielding new resources for future growth.
Finding your stem tip requires patience to observe the baseline and precision to act only when necessary.
It is incredibly elegant, but as much as I love this framework, I keep thinking about our documentary crew from the very beginning, The Observer's Dilemma.
Oh, right. It brings us to a rather profound final thought.
We started by asking how to observe a living thing without it falling apart. The author found a brilliant compromise by taking those stem tips to encourage bushiness. But if we go back to the biology, if taking those cuttings successfully stops the auxins and fundamentally changes the chemical structure of the Coleus to make it bushy, which is undeniably not its natural, unmanipulated shape, at what point does our minimal intervention permanently alter the very wild environment we originally set out to simulate?
This raises an important question, doesn't it? The moment you snip the tip, the plant is no longer wild. It is reacting to you.
Even the absolute smallest intervention shifts the entire trajectory of the system. We remove the terminal bud, and we fundamentally change how the organism grows.
It is the Heisenberg uncertainty principle applied to living systems.
So, wow. Yeah.
In quantum mechanics, the very act of observing a particle changes its behavior. In botany and in management, the act of caring for a system enough to ensure it survives means you will inevitably change its nature.
You cannot be in the room without changing the temperature. You can't manage a team without your presence altering their natural dynamic.
The question we want to leave you with today is to reflect on your own role as an observer and a caretaker. When you step into a new environment and attempt to establish a baseline, are you ever truly just observing? Or does the responsibility of maintaining a system, of keeping it from becoming structurally sparse and collapsing, mean that pure observation is actually an impossible ideal?
The observer is always part of the ecosystem. The moment you decide to care, you become the environment.